Okay, so these are the notes for 6.2, where we're going to take the normal distribution information that we learned last time, and we're going to apply it to contexts. We have the same formula for finding z, so we can apply it to the standard normal curve. And these are the steps that we're going to use every time. We're going to draw a bell curve. We're going to find the z value for the information given to us, and then we're going to use that z value in our table to find the approximate area, or area to the left. Okay. Survey found that women spend on average $146.21 on beauty products during the summer months. Assume the standard deviation is 29.44. Find the percentage of women who spend less than $160. Assume that it's normally distributed. We're going to start by drawing our bell curve. I'm going to put some labels in it along the way. Okay. Right here in the middle is our average, which would be 146.21. And then we're being asked about the probability of being, whoops, sorry guys, you're seeing behind the scenes. Okay, there we go. And the value that we're being questioned about is 160, which would be over here on the right somewhere. And we're looking for the percentage of women who are less than that. So we're going to say to the left, because that's where less than would be. And we want to know that area under the curve, because that area is the probability of landing over there. Okay. So the next thing we need to do is find the z value for the 160. So the z for 160 will equal 160, the value we're worried about, minus the mean, 146.21, divided by the standard deviation, which I believe was 29.44. I'm going to grab my calculator and make this calculation. Clear that. Okay, so 160 minus 146.21. Then we divide that by 29.44, and we get 0.468. Now, our chart only goes 2 decimal places, so we're going to have to round that to the nearest tenth. So I'm going to call that roughly 0.47. So I'm going to take that number and I'm going to go back to my z table that we used last time. I'm looking for a positive number, so I'm going to come to the positive table. 0.4 is right here. I need to go all the way over to 7, which is unfortunately off the screen somewhere. It's over here. Let's see if we can find that. There it is, 0.6808. And because I'm looking for the left-hand side, I can take that number and record it as my answer. Area to the left of z is 0.6808. Okay, or 68% of women are spending less than $160. Well, each month an American household generates an average of 28 pounds of newspaper for garbage or recycling. We assume that standard deviation is 2 pounds. If the household is selected at random, find the probability that generating between 27 and 31 pounds per month. Assume it's normally distributed. Again, we start with drawing ourselves a basic curve to do our thinking with. Right in the middle is 28. That's the mean. But we're talking about going from 31 to 27, and we want in between those. So this is one of those in-betweens where we have to take the right value minus the left value. And so we're going to start with, we need to find the z of 31, and we need to find the z of 27. So this would be 31 minus our mean, which was 28, divided by our standard deviation, which was 2. Over here, we're doing 27 minus 28 all over 2. These numbers, I just have them off the top of my head because I'm looking at it, but if you're wondering why do I have 2, it's because the problem said the standard deviation was 2. So all these numbers are coming from the chart that we're reading off of. This first one comes out as 1.50. We always want to go to that second decimal place. And here we get negative 0.50. So now I need to find those two. This is step 3. Find the area between. Okay. And the way I'm going to do that is go to the z table and find 1.50, which would be 9332. So the area to the right, or to the left of 31, sorry, is 0.9332. And then the area to the left of the 27, which was negative 0.5. So I'm going to go up to the negative chart. Negative 0.50. Be right here. 3085. .3085, and if I want the area in the middle, I do it by subtracting those two numbers, which would be 0.9332 minus 0.3085, and I get 0.6247, or 62.47% of households are going to fit that description. Now sometimes we need to find a cut score or a value that produces a specific probability. And so for us to do that, we rewrite the z equation. Z equals, x minus mu all over sigma. If you were to rewrite this and isolate the x, you would multiply by sigma. That's why we have z times sigma. And then you would add mu over. And so this is just a rewrite of that equation. But when I'm looking for the value that produces a specific percentage, that's the formula we're going to use. So to qualify for Police Academy, candidates must score in the top 10% of a general abilities test. The test mean is 200 and the standard deviation is 20. So find the lowest possible score to qualify. So if I look at this, I draw my little bell curve. Right here in the middle is 200. And there's some score over here that means this is going to be the top 10%. That's what I'm looking for. But in order to figure out what that number is, I'm going to need to know what the z is from the chart. Rather than saying z is mu or x minus mu, I don't know what x is, so I can't use this formula here because I don't know what x is. So I'm stuck trying to find the z value from the chart. If it's 10% to the right, that means this space that I want to be above is 0.90. That'd be 90%, right? So 90% is to the left. So I'm going to go to my chart and find 90%. 90% is going to be in this chart somewhere, but I know it's on the right because it's bigger than 50, so I'm going to go to the positive chart, and then I'm just scanning and looking for something close to 90. That's 88, that's 89. I'm going the right direction. If I come down, I've got 90.32. That's maybe too big. I've got 89.62, 89.80. This is getting pretty close. But I'm going to need to see if there's anything better on the other side of the screen here. Let's keep coming. Ooh, there's some good stuff. If we look, we've got 89.97 and 90.15. So which one's closer is going to be this guy right here, 89.97. So I'm going to go ahead and use the z value. That's a 0.08. So it's 1.28. So I can come back to my notes and say that the z value that separates these is 1.28. That's going to create this line right here that separates the lower 90 from the upper 10. So now I can just plug this into the equation. X equals my z, 1.28, times the standard deviation of 20 plus the mean of 200. And I can just put that into the calculator. 1.28 times 20 plus 200 gives me 225.6. So this means that if an applicant scored above 225.6, I know that they're in the top 10%. And if they scored below that, I know they're not in the top 10%. So this gives me a threshold for scoring people and determining the outcome of that score. All right, good luck, guys. We'll see you in class.